Okay, so this is the starting point of the project, starting with ResNet50, for which I have to import the dataset, which is why I have to use this. And using Kaggle website, I can download the dataset of Food 101 and unzipping the dataset. And here you can see the dataset still here. Unzipping the folder and installing split folder so that dataset splits into 80% and 20% based on the given ratio, and so that we can separate dataset into training and testing categories. And this is a simple defining of variables, defining classes and sorting the classes to finally predict the item, installing some required dependencies, now performing data augmentation, uh, defining the transforms of which we need to sorry of which we need to apply on training and validation datasets. This is the function to visualize the dataset. Visualizing appears something like this, and this is the code where importing the pre-trained model, and this is the freezing the first few layers. I am taking 100 as a parameter and then modifying the final layers to match our number of classes. Like, since our dataset is 101 categories, the output of the model should have 101 dimensions. So again, installing some required dependencies using cross entropy loss for loss function and ADAM optimizer for optimization. This is to check whether the GPU is enabled or not. And this is the model training where the iterations of model training happens. Training actually takes more than 6 hours, which is why I have done the training beforehand. This is the output that I will get. The accuracies also match with the output files that I have acquired over here. No need to worry. And saving the model and loading the model for further prediction. And this is the result analysis where I can acquire the accuracy and loss functions. And this is the prediction code where the ResNet50 is loaded and image is passed into the model to predict the class. This part is actually the ensemble code, which is executed after we go through the Inception v3 model. This is the Inception v3 model code, importing some required models and the same dataset training and validation dataset folders. These are some just exploring the dataset, like how many pictures are there of each category, and these are the classes that are present in the food dataset. These are the transformations that will be applied on image dataset. The point to be noted is the transformations that are applied to training dataset are not same as applied to the testing dataset. And printing image data after applying the transformations. This is the pre-trained model of Inception v3. Here also we use the cross entropy loss function and Adam optimizer. The same for modifying the final layers to match our data set. This is the freezing of first few layers so that the weights of the pre-trained model remains the same. And this is where the training happens, and this to calculate the accuracy, to calculate loss, and this is the iterations of each epoch. Here you can see the train batch function which is defined here. So after each epoch the model trains for itself, and at the end of epoch 9 the training accuracy remains at 83% and validation accuracy remains at 68%. Saving the model and predicting the model. Predicting the class of the food item. Now, since we have saved both the models, we can just use the ensemble code to unify the two models, which comes here. These are the transforms that were to be applied for each model. For ResNet50, the input size is different, and for Inception v3, the input size is different, which is why I have to apply two separate transformations for the same input image. Here I have taken a few testing images out of the dataset. These images are present here. This is the same image which was present in the food 101, this is a non-food item. The same goes with this, and the same goes with this. This is the out of the food 101 dataset, and let's go to the code. The path of the images are taken to this variable, the list, and for each image the image is open and applying the transformations of ResNet50 and Inception v3 on each image, and transferring the image to the GPU and passing it to this function. This function goes back to the constructor calling, where the constructor is called and models and inputs are associated with the object, and then this forward function is called so that the x will remain the inputs input images which are present here, and self dot models are initialized here, and self dot input sizes are also initialized here. Now this function goes back to here, sorry, here, which takes inputs models and input sizes as parameters, arguments, and here the transformations, the input sizes, the images are resized to match the input size of each model. uh, the output of each model is appended into an output list. Applying softmax function on the output and making the average probabilities of each model. Finally, the predicted class dot item gives us the name of the item, and the predicted class probability is the mean probability of two models, and item multiplying it with 100, and the output will be something like this for chicken curry image, which is which is I have shown you this image. Let's see the and see the nutrition values. Calories is 124. By the way, this calories and all the nutrition values are per 100 grams. And the second picture comes for baklava, which scores 99% since it is from the training data sets itself. But this image is from the out of the box, but it also gave me 98%. And let's see the non-food item. Yeah, the predicted class is non-food. This one is also non-food. This one is also non-food. Yeah, as you can see, the probabilities are pretty low: 18%, 13%, 45%, and these are just the functions to predict for one model, like either for ResNet50 or either for Inception v3. Let's look at Nutrition 101 CSV file. This is the CSV file that provides the nutritional values and calorie values for 101 items. These values are for 100 per 100 grams of food item. So yeah, that's it. Thank you.